You're listening to the Podcast Engineering Show, and this is session number 15. And here's my band. Not really. That's right. Welcome to the show. This is where we rock out, talk podcasting, have great guests. We got a great one today. Oh, my goodness gracious. Strap on your seatbelt, people. I am Chris Kern. I produce podcasts for companies and business authors. I work with Forbes, Dun & Bradstreet, and a lot of really cool business authors. Every week on this show, we bring you podcast engineering and production techniques and tips. We talk with experts who are out there doing it. And if you listen to this show and you take the best from this show, man, you'll enhance your skills like crazy. I got into podcasting about 4 years ago. I have a background in audio music engineering. And when I entered podcasting, I realized that a lot of podcasters, most podcasters, don't have any real audio engineering skills. And it's really important. I mean, the audio is all you have to present to people. So the quality of that audio and the character of that audio is very important. So on this show, again, it's all about the sound and the workflow and the techniques that you can use to engineer and produce shows for better quality and for quicker production, right? Time-saving tips. We talk about that. Of course, Barry is with me, and I'm remembering to turn off the theme song. Barry, you ready to go?
Yeah, oh yeah.
Okay. Barry, did you hear the last episode of this show? What'd you think?
There's no activity, no giggle, no nothing.
Really? Dude, it was a good show. Oh my God. All right, Barry. This show is brought to you by two companies that I am involved with. One is the Podcast Engineering School. That's right. We are creating a school to teach podcast engineers and producers how to have all the skills necessary to either start a business doing it or be hired from a company doing it. There's a lot of companies looking out there for podcast engineers and producers. There's job postings. So in order to get that, maybe you could attend the Podcast Engineering School, get everything you need, boom. So podcastengineeringschool.com, that's the website. And of course, my production company, Fractal Recording, providing the highest quality podcast production to companies, authors, and podcast networks. Fractalrecording.com. If you go there, you can see the Fractal Pterodactyl. He's our what do you call him? Mascot. He's our mascot. You can listen to this show anywhere you hear a podcast. Our guest today is Steve Savanyu. That's right. You might not have heard of him, but after today, my God, you're going to want to email him and go find him and shake his hand, probably. He's the Director of Educational Services at Audio-Technica U.S. And Steve, I guess Audio-Technica U.S. is different from Global or something?
Well, Audio-Technica is actually a Japanese company with our headquarters in Tokyo, and we're the U.S., North American, South American sales distribution office. And we do a little bit of manufacturing as well here, but we're actually a Japanese company.
Nice. Do you speak any Japanese?
None at all, but I do like sushi.
Oh, all right. So you are responsible for all the aspects of training, management, and content creation and educational support at Audio-Technica. You have over 40 years of professional audio experience in live sound and studio and broadcast applications. This is awesome. I want to hear, hopefully, in fact, maybe this episode for the speed round, instead of it being, describe your production and workflow, we can have you describe your 40 years in a speed round. That'd be cool. You've worked on you've worked on a lot of huge events, including you recorded the president and the Pope, not at the same time, probably.
No, not at the same time. We actually provided microphones for both applications, and two popes and one president that I've been involved with.
Right. This is awesome. So I'm sure most people listening to this show have already heard of the ATR 2100 USB microphone, which is probably one of the most popular podcasting microphones on the planet. Well, it definitely is. It's definitely one of the top three, I would say. I mean, everyone knows it. Everyone has one. It's inexpensive. It sounds really good. So we're going to talk about that mic, but we're going to talk about a lot of other mics as well. We're going to talk about setups, like equipment setups and common mistakes you've seen, Steve. But let's start with that speed round. Describe your 40 years in a speed round, if you could.
All right, so I have like 30 seconds to do this, correct?
Let me start the clock.
Okay, go. Well, I started out doing audio as a sound contractor back in the early days, late 60s, early 70s, and just kind of continued from there. And I've done recording, I've done live sound events, sound for bands, sound for contracting things. I've installed sound systems in some of the weirdest places in the world, and currently at Audio-Technica, I've been here 16 years doing educational services, training, product management, and other aspects of our business, and done a lot with a lot of different microphones, mostly ours, obviously. But I've played with some, I collect microphones as well, so I've got some pretty cool vintage mics in a microphone collection that some are older than me.
Oh, that's cool. So wait, you've been at Audio-Technica for 16 years. That means
16 years.
When you started, there was no such thing as podcasting. So tell me, when did you first hear of podcasting and what was your impression?
Well, I first heard of podcasting right when it was in its infancy, and the product that we had come out with was the Audio-Technica AT2020, which is the side address condenser microphone that still retails for like $100. And that was one of the original go-to podcast microphones, but you still had to have an interface. You still had to have external equipment to plug that in to your computer system. With the some of the new mics that we have with the USB outputs, you now can do a basic podcast, a one-person production with a single microphone. So if it's a corporate person doing a training piece, or if it's a podcaster that's just producing shows, this basic microphone is a great way to get started. You can just plug this guy into a computer. There's no drivers, no software. It works with all the recording software. It works with all the podcasting software. In fact, I'm using one right now on my end of this whole broadcast.
All right, but you're wearing a headset, so it's an Audio-Technica headset?
Yeah, I have a special headset that we don't actually make here in the U.S. It's offered in Japan, and I picked one up through a friend of mine that was coming back from Japan, and I use it just because I can do hands-free stuff. I talk with my hands sometimes. So You can't see this, but I'm doing all kinds of great hand movements as I'm talking. Well,
that's some of the perks of being the education guy at Audio-Technica U.S. That's awesome. Right, so when podcasting started, the AT2020, which you can still get, on your end, how have you seen podcasting grow? Are more people asking you about podcasting mics over the past, let's say, 5 years?
Well, it's interesting because podcasting has kind of grown in that it started out as something that, people were just kind of doing to sell their hobby, for lack of better terms.
Right.
And now you're seeing corporations using podcasting as a training tool. You're seeing podcasting being used as like another form of radio broadcasting, for lack of better terms.
Right.
And that you're seeing people saying, I really want to get into, getting the word out on something that's really cool, whether it be sports, whether it be, hobbies, whether it be corporate training events. And it's like this internet broadcasting. I don't need to have a big radio transmitter anymore. I don't even need to have a big commercial radio studio. I can do this in a conference room in an office building. I can do this in my living room. If I'm a traveling person that does a regular podcast, I can do it from a hotel room. And that's because the technology that we have available today has made that so much easier than back when I started. You had to have a radio studio to do any kind of a broadcast or recording.
Right. All right. So on this show, you're talking to podcast engineers and producers. Why don't you tell our audience what, I'm sure you have several, but what is one really good sounding setup that you've seen? Good mic, good audio interface, whatever. Just a nice setup that sounds really good. I mean, because obviously you're a sound guy and you like good sound. I mean, you hear these podcasts that sound horrific and you can't stand them either, right?
Right. Well, it all starts with the microphone. And I look at a microphone as an investment. And having a good quality microphone that's purpose-built, that's designed for what you want to do. There's several different things that are out there that are available today. The second thing is we have to disseminate whether you're doing a multi-person podcast. If you're producing a show, and I'll just use the word show and podcast interchangeably. If you're producing a show that has multiple guests on it and you're hosting it, you need to have a microphone for every guest. No doubt about it. Because you want those guests to be close to their microphones. One of the worst things that I've heard is someone sets a single microphone up on the middle of a table and they've got 3 guests in their show, plus the host, and they're all talking, and it sounds echoey. It's difficult to hear what the people are saying, and that's just because of the laws of physics. I can't bring people closer with a microphone unless I get them close to the microphone. So we look at this in a couple different ways. Now, there are some ways to get around this. If I'm doing a two-person interview, I'm interviewing a guest, and we're in the same room, we're sitting across from the table, I can choose a microphone that has a certain type of pickup pattern, we'll talk about pickup patterns in a moment, that allows me and the guest to talk, and the microphone will pick us both up equally. On the other hand, if I'm doing a show that has multiple guests, then what I want to do is I want to have microphones that have directional pickup patterns so that the microphones are picking up each guest and then rejecting sound from the other directions to minimize the pickup of unwanted sound. And that's going to help keep the echoes down in the situation. Now, the classic scenario is we've got a room set up to do a podcast in, and it's not really a studio per se. There might be a minor amount of acoustic treatment. There might be drapes over the windows that we can close to soften the room up. If I set that single mic on the table, it's going to sound echoey. It's going to sound distant. It's not going to sound up close and personal, which is part of what we want to do with a podcast. We want to make it sound as if we, the people in the podcast, are carrying on a personal conversation with the listener. So it sounds like we're all together side by side or up close and personal.
Right, yeah. So if people are in person, you have to have the different mics and the different, each person has to have their own mic. I know with Forbes, some of the hosts do in-person things, and we use a Blue Yeti, and it has a figure 8 pickup pattern, so it's good to put between the two people, and it picks up both people and rejects stuff from the sides. I mean, that's better than having the Blue Yeti in just the Omni mode, picking up the whole room, but it's still, in my opinion, not better than having, a dedicated, sort of handheld microphone, 2 inches from each person's mouth. You know what I mean?
Well, let's say we'll take a look at a podcast scenario with, say, 2 guests and a host. So each person has their own microphone. The microphones are cardioid pickup pattern microphones. And that allows the guests and the host to get close to their microphone. Now, an interesting thing about microphones, if you want to get that big, deep AM radio sounding voice, work your microphone closer. The other thing you have to be aware of is when you have a guest, a lot of times people are afraid of the microphone, right? You bring somebody in that does not have experience. They're going to be a guest on your show. And you put them in front of a microphone, and all of a sudden they become afraid. They back away from the microphone. So you want to have a microphone that's sensitive enough that it's going to pick that person up. Some of the common handheld dynamic microphones that are popular today are not the best choice. If you look at most radio studio microphones, they're usually a larger microphone. They might be an end-addressed microphone where you speak into the end of the microphone, or they might be a side-addressed microphone where you talk into the side of it. The other thing is a condenser microphone versus a dynamic microphone. A condenser microphone is going to be a little bit more sensitive. So if you've got a quiet talker, a guest being a talker, if you've got a quiet talker, it's still going to pick that person up, but they don't have to be as close to the microphone. Because some people absolutely are intimidated by microphones.
Oh, yeah, totally. And then you have to, in my experience, what I've done is, you put the mic there and they sort of seem to just shy away from it a little. And then, I'll walk away and do something else for like 30 seconds. Then I'll come back. I'll move the mic a little closer and say, it's okay. You have to be close to the mic and then, then walk away again. I'll come back and do that again if I need to. It's like this psychological game you have to play with people. It actually happened to my dad. He came to my studio. Well, my mom and dad came to my studio in New Jersey. And, my he tells stories, he tells jokes. He's a fun guy. And we got on the mics and he just clammed up. And it was so funny. And it was just like the look in his eyes. You could see. That's interesting. So yeah, look, I think maybe you have an answer to this. I've had a lot of people who stay far away from the mic, and you can crank up the mic pre to get more level, which is actually dangerous because then if they kind of lean in and get close, they're going to blow it out. But if they're far away and you have to crank up the mic pre a little, you're picking up a lot of room noise. Is there any way around that, Steve, that you've seen or heard?
Well, one thing you can do is I've seen some people use a directional microphone, which we call a shotgun microphone. And some voice actors will use this as well. And you can work that microphone a little bit further away because it's got a very narrow angle of rejection. And if you do move in close on it, because of the design of the microphone, it's less likely to overload or pop. Another tool that you can use, depending on the interface that you're using or the control unit that you're bringing the microphones into, some of the digital mixers that are out there have a built-in compressor. And what the compressor is going to do is it's going to level out those variations. So if the person backs away from the microphone, it's still going to pick them up. But if all of a sudden they lean into it for whatever reason, or they shout or they get excited or nervous, the compressor is going to kick in and minimize that potential for overload. And a lot of digital mixers have that. A lot of recording software has that you can actually insert those as plugins onto the channels if you're recording it for future broadcast.
Right. So let's move over to talk about if someone's connecting over the internet. I mean, like we are now. You're wearing a headset. I'm actually using a Shure SM7B. You know, and for my clients, I have guests connecting from all over the country and all over the world. I have several computers, and I'm bringing them all in, and I'm kind of sound checking them. And I continually have to coach the new people. You know, like you're wearing a headset, you know how to use the headset, you plugged it in and it works and everything. But I, day in and day out, I'm struggling with people trying to explain, no, you have to wear headphones. You can't just have your speakers playing in the room. How do you coach people in that regard?
Well, what I recommend is if you're going to do this on a regular basis, you really do need to have a microphone. And like I say, the 2020 USB Plus or the ATR 2500 USB, both of these microphones have a built-in headphone amplifier in them and a built-in headphone jack. They're both USB. They don't require any software or drivers to make them work. You literally plug them into the computer. My headset's the same way. I plugged it into the computer, Google Chrome, found it. I went in and just said, yes, use the Audio-Technica headset on the little selections that came up, and away we go. You definitely need to have headphones on as well, because what happens is if you don't have headphones, you're playing it back through the speaker in the computer, and you've got a microphone picking it up, you're going to get this kind of oscillation sound or regenerative echoes or even a feedback type effect because of your microphone is also picking up the sound of the far side audio, which would be Chris in this case to me, and I would be the far side audio to him. So it's picking that up as well and basically rebroadcasting, and that's going to give you that regenerative feedback sound that sometimes you hear. So you definitely need a decent pair of headphones, and you need a decent microphone. The beauty of that is for a guest is a remote microphone that's USB enabled works out really, really well. There's no other things they have to do. They plug it in and it's plug and play, and away they go. Windows or Mac, it doesn't matter.
Right. So you mentioned the ATR 2500 USB. So I think most of our listeners will know the ATR 2100 USB, which is a handheld cardioid. It's a dynamic mic, and it actually has an on-off switch on it too, which is one of those things where sometimes you have to tell people, make sure the switch is on. But you mentioned the ATR 2500 USB. It's actually a cardioid condenser USB mic. Now, you know, in podcasting and really anywhere, it's well known that condensers pick up a lot more. They're much more sensitive. So is the ATR 2500 going to be one of these mics that, you know, picks up all the room noise as well?
The ATR 2500 it's a little bit more sensitive than the dynamic, so you can work it a little bit further away. It also has a built-in headphone output in it, so you can drive your headphones. What I like about the condenser microphone over the dynamic microphone for some applications is it's a little bit more articulate. So you're going to pick up a little bit more of the voice. You're going to hear the articulations in the voice. If you're dealing with a softer talker, it's going to pick that talker up. Whereas the dynamic microphone, which also has its benefits, is going to be, you have to be a little bit closer to it. You have to be a little bit more on it. So if you've got someone that wants to sit back and talk, then I would use the side address condenser.
Right. So a lot of podcasters, they don't have a real studio. They don't have any soundproofing. They might have some foam up on the walls. And it's been my experience that, you know, condenser mics really, I mean, unless you have some soundproofing or sound deadening, condenser mics pick up way too much noise. Now, that depends on, like, you know, if there's an air duct right behind you, or if, you know, the lights are making a little bit of noise, you know, like the different things that can make noise. If you don't have much noise, a condenser can be okay. But I mean, the chances of a podcaster recording or broadcasting from a space which is really, really quiet is very rare. So I think that's why most podcasters use dynamic mics. What would you say, what can someone do to their studio space to make those background noises less?
Well, it's just basically a lot of good common sense. The more soft furnishings in the space, the better you are. I know voice artists that travel, and the problem with being a voice artist is you're always on call. We need a read for a project, and so they'll carry like the ATR 2500 or the 2020 USB microphone plugs into their computer. And then what they'll do is they'll take all the couch cushions or the bed cushions or the bed duvets, and they'll make like a little voice booth, for lack of better terms, just to soften things up. It doesn't look very pretty, but nobody can see it, and that'll help a lot. I know people that do, they've got to do a recording for some situation, and they'll do it in the walk-in closet of their home, or a clothes closet where there's lots of clothes hanging because they're soft and they're absorbent. If I'm in a conference room, I've got a conference room attached to my office. It's absolutely the most horrendous place to do any kind of recording, because it's got windows on one side, it's got a hard top conference table in the middle, it's got hard walls on the other three walls, so it's really not a pleasant place to record. But even something as simple as, you say, foam, anything that softens up or absorbs is going to help minimize those reflections. Sometimes too, keeping the level down and working the microphone closer, even with a condenser microphone, is going to minimize those reflections. Again, it's the guy that sits 5 feet away from a microphone, sitting in the middle of the table, that wonders why it sounds like it's 5 feet away from the microphone.
Yeah.
A microphone is not a zoom lens. I can't zoom in on the voice. I can only get the voice closer by either moving the microphone closer to the voice or moving the voice closer to the microphone.
Okay, that's great. I want to ask you about a little personal question that I've been thinking of, but after that, I want to ask you about the microphone technology and also about the rejection, how the mics create that rejection. I think it's with phasing, but I want you to tell me. But first, my question, this is what I want. This is like something on my wish list I haven't been able to find, and Audio-Technica might not make it. It's okay. I'm looking for a microphone that I can have on my person. So here's what happens is when I, do local meetups or I go to meetings, people ask me questions and I end up talking, and I end up I'll talk for 10 or 15 minutes about let's say podcasting, and it'll finish and the person will be like, wow, that was great, thank you, and they'll walk away, and I'll be like, man, that was a great answer, I wish I had it recorded. So I almost want a microphone on myself that I can just have recording all the time, but I don't want other people to see it. I don't want other people to see, a lapel mic or a headset mic. I almost want a hidden microphone just for me. I mean, is that a completely ridiculous wish, Steve?
No, not at all. We actually, years ago, the Three Tenors did a performance that was recorded and broadcast. And of course, every opera singer worldwide will not sing into a microphone because they're opera singers and they don't use microphones. But we had to pick the sound of the Three Tenors up for broadcast. So what we did is we took a sub-miniature lavalier microphone, and I wasn't involved in this, but someone I worked with was. And they bought some really fine cross pens. And they took all the guts out of the cross pens, and they mounted the microphone inside the cross pen. And in the tip of the cross pen, if you've ever seen a cross pen, it has a little dimple in the top. They drilled the dimple out and shoved the microphone up inside the pen so that the capsule was pointing right aligned with where that little hole was. And they put the pens in the pockets of the Three Tenors, and they ran them down to body pack transmitters for a wireless system. And the Three Tenors walked out wearing their coats with their body pack transmitters in them, with a nice cross pen in their pocket. And they sang all night, and they got the recording they needed and the broadcast they needed, and there were no microphones to be seen.
Wow.
So that's the way you could do that, using a lavalier microphone, feeding a little pocket recorder in your pocket, and hidden inside of a pen, like a standard cross pen or equivalent.
Right. All right. Now I got to get. Does AT make one of those?
We don't make one of those. The only comment I'll put, I have to put this disclaimer in, is any time that you record somebody, you have to let them know they're being recorded, because there's potentials for litigation if not.
Yeah.
If you record somebody against their will or they don't know they're being recorded, which is why when you record a telephone conversation, there's a beep that happens every 15 or 30 seconds, because that's required by law.
Oh, okay. Yeah, I don't want to record anyone else. I just want to record myself. And
Sure.
I don't even really need to use the audio. Literally, it'd be nice if I could record it at high enough quality so I could use it on, for instance, we have a meetup called Pause Your Life, and it's about just stopping and pausing your life and just being a human being and just dropping all your baggage. And we talk a little bit about spirituality and mindfulness, things like that. And I have a podcast show called The Mystic Show. So it'd be great during these meetups, we're talking about this stuff, and I might may give some good answers or have some good ideas. I can just record myself and then come home and transcribe, what I said and just use it as a blog post or something. I don't want to record anyone else.
Sure.
And I don't want to use it.
Again, the method of hiding the microphone, I do a lot of stuff with film actors, and you can hide microphones on film actors that you can't see them with some of the sub-miniature microphones that we make and others make. That pretty amazing.
So it's called a sub-miniature mic?
Sub-miniature lavalier microphone. A BP896 is one that's in our catalog, and AT899 is another one that's in our catalog. And both of those are really high-quality lavalier microphones that are quite tiny.
Interesting. All right, so maybe you do have my solution there. Anyway, so microphones have been around for probably 100 years, right?
Since the early telephone days. The original microphones were actually the transmitters for telephones.
Right, and that was
way back there, back in the late 1800s, early 1900s, if my dates are
right. Yeah, something like that, right around that turn of the century. And then, of course, I know the Germans made some progress with the Neumann mics and whatever, and all that. So we have condensers, we have dynamics. We've had these kind of microphones for, at least 70 years. Has any of the technology actually changed significantly, or are we still using the technology from whatever 70, 80 years ago?
Well, it's interesting. You look at electronics today and recording equipment today, it's like buying a car. You buy this brand new piece of audio hardware, and the day you walk out of the store, it's depreciated in value quite a bit, especially some of the old analog equipment. Microphones, however, have held their value over the years. I have some ribbon microphones that were made in 1939. I've had them tested, and they all work, and they all are up to specification. And those microphones probably cost maybe $1,000 in 1939 dollars, and today they're worth considerable amount more, and there are guys that would love to have them to use in their studios. So microphones do hold their value. It's one of the few things in electronics in our industry that maintain their value over time.
Right.
Some of the technology, there's several types of microphone technology. There's crystal, ceramic, and carbon that were some of the original technologies, which you don't really see too much anymore. Harmonica players like crystal microphones, and if you have a relative that has a really old telephone in their house, like one of those big ones that hung on the kitchen wall that crackles when you talk to them, that telephone probably has a carbon transmitter in it. If they whack that transmitter on the table a couple of times, it'll loosen the carbon granules and that static will go away. Those technologies are pretty much gone. The technologies that we're still used today are the dynamic, which is the moving coil microphone, the ribbon, which is a corrugated foil ribbon suspended inside a magnet, and the condenser or capacitor microphone. And it's interesting that the ribbon microphones in the 50s and 60s fell out of favor for the condenser microphones, and the ribbon microphones are making a comeback because of the digital recording age that we're in today.
Interesting. How is a ribbon suited better for digital recording?
Well, if you look at digital recording, in the analog days, so if you're doing a recording, every time you did a generation bounce down or you did a generation dub down, you lost a little bit of high frequency response. So engineers, whether it be radio engineers or recording engineers, knowing that they were going to do mix downs or do dub downs, would record with a condenser microphone that had an extended top end. That's that sensitivity here of the high frequencies. They would record it hot, and they would record it bright, knowing that after they did the dub downs or the bounce downs, that by the time they got it to the point where they're going to do the final master, the top end was where they wanted it. Or they could always go in and equalize out a little bit of high end if it was still too high.
Right.
The problem when we went to the digital world is the digital recordings, every time you do a generation dub or a bounce down, including a podcast, if you record a podcast and you go back and you edit it and then you bounce it down in the digital domain, nothing changes. It stays the same.
Right.
So engineers were recording with the old analog techniques, record it hot, record it bright. And they do all their bounce downs and things. They'd get the final recording, they go to master it, and these digital recordings sounded brittle,
right,
sounded harsh. And they couldn't figure out why. And it's because of the recording techniques, because there was no generation loss. So then they discovered these old ribbon mics that were laying around in the back of the mic cabinet that had gone unused for several years. And they put those up and they started recording with the ribbon microphones, and they got a nice warm bottom end, and they got a nice smooth top end that wasn't overly bright, that made the ribbons extremely popular in the digital world today. We make 2 ribbon microphones in our line. I know most of the major microphone manufacturers offer a ribbon, and there's a company that actually has gone out and has recreated some of the original RCA style ribbon microphones from the 40s and 30s, 40s, and 50s, and they're marketing them as remakes, and they're pretty amazing sounding mics.
Huh. Are they cardioid or omni? What are they?
Well, ribbon microphones by design are bidirectional. Bidirectional meaning they're going to pick up equally from the front and rear and reject sound from the sides. And microphones, it's interesting, microphones are all born omnidirectional, meaning they'll pick up equally in every direction, which is why when you see a newscaster wearing a lavalier microphone, it's upside down, i.e. the wires coming out of the bottom of the microphone's facing up towards their mouth. It's an omnidirectional microphone because it doesn't matter which way I position it. Now, the ATR 2100 that people use, the ATR 2500 that I'm talking about, the USB 2020, and so on, all of those microphones are cardioid or directional. They've got a heart-shaped pickup pattern. They're designed to pick up sound from one side of the microphone, the on-axis side, and reject sound from the other side of the microphone or the off-axis side.
Right.
Now, what's important to note is the better the microphone is, i.e., I'll say more expensive the microphone is, or the more consistent the microphone is. The goal is as you move off axis, you want all the frequencies to drop in level at the same rate.
Oh.
And some inexpensive, you find these microphones online, you buy 3, get 6 free package deals. And some of those microphones, as you move off axis, they drop off on some frequencies, but not all frequencies. And so those frequencies that they don't drop off with as you move off axis are sensitive to sound, and they could pick up room noise, they could pick up, they could be acoustic feedback if there's monitor loudspeakers being used, et cetera, et cetera.
Right.
So it's important. And one of the things that Audio-Technica does is we strive on consistency, that our off-axis response is consistent across the frequency range of the microphone.
Yeah, that's important, man. So are all ribbons bidirectional or just most?
Well, all ribbons are basically bidirectional. I do have a 1950s RCA ribbon microphone in my mic collection that has a little switch on it that you can basically put a port or close a set of vanes behind the ribbon that makes it more directional. But most ribbons by nature are bidirectional. It's by the way they're manufactured, the way they're built.
Okay. Now, I wanted to ask you about the directionality of microphones. Like a cardioid pattern, like you said, it's a heart-shaped kind of pattern, and it only picks up sound from one side, for the most part. And as you move off axis, the sound level it picks up goes down and down and down. How? And you said before, actually, that all microphones start out as omnidirectional. How do you take an omni and make it a cardioid?
That's the secret sauce or the hidden magic that each microphone manufacturer does.
I see.
It's all physics. I mean, we're dealing with laws of physics that cannot be broken, but we can utilize those laws to our favor. And what microphone manufacturers have found out, what we found out is basically sounds. You have 2 sounds. You have sounds that are in phase and sounds that are out of phase. And phase is a wave relationship. So the example that I use in all my classes is, I'm from Ohio, so I use an Ohio landmark. Imagine the racing roller coasters at Kings Island down by Cincinnati, right? And they start off together, the red train and the blue train, and they go over a series of bunny hills, right? They're like a sine wave. And as long as the 2 trains are side by side, they're basically in phase. So their signal outputs, if they were audio signals, would add together. As the blue train gets a little bit ahead of the red train, or vice versa, then the signals become out of phase. And what happens is out of phase signals will cancel each other out. It's the magic of what makes a balanced microphone line not pick up noise. It's the magic that makes a directional microphone directional. So what happens is through something called an acoustic labyrinth, which is where sound hits the back side of the diaphragm, slightly delayed, acoustically delayed from the sound hitting the front side of the diaphragm, and that will cause cancellation, and that will make the microphone directional. So we can utilize that to our advantage, and that's what the microphone manufacturers have done. And if you were to take the head case, or the top, off of the ATR 2100 microphone, you would see the capsule in the microphone. And around the base of the capsule, you would see a series of small holes covered by a screen mesh thing. And that's the entrance to the back chamber of the microphone's diaphragm. And sound enters those little holes and hits the diaphragm slightly delayed from the sound hitting at the front, and causes phase cancellation to occur, and it makes the microphone directional. Which is why when you see certain vocalists cup their microphone, all of a sudden it starts to feedback, and the high quality sound that they were getting before they cupped the microphone goes away, because they basically covered those little openings up, and now the microphone's a really bad Omni, even though it's a great cardioid mic.
Oh, wow. That's interesting. So you're talking about the diaphragm. Dynamic mics and condenser mics both have diaphragms, right?
Correct. A dynamic microphone, I'll go back to fundamentals here,
Sure.
just so we all understand. A dynamic microphone is like a little loudspeaker in reverse. In fact, a loudspeaker is often used as a microphone. If you've ever gone to a fast food restaurant and you're in the drive-thru, you're out at the menu board, and the person behind the window says, "Would you like fries with that burger?" And you say, "Yes, I'll take the supersize." More often than not, the loudspeaker that they were talking to you on becomes the microphone when you talk back to them in the drive-through intercom. So a loudspeaker can be used as a microphone. I've actually taken a small loudspeaker and made it an input to a sound console and used it to record the subharmonics of a kick drum to get the really low frequencies of a big kick drum.
That's awesome.
So a dynamic microphone works just like a loudspeaker. We've got a diaphragm of a plastic material attached to a coil of wire that is suspended on a paper core over a magnet. As air hits the diaphragm moves back and forth, moves the coil of wire over the magnet, and 7th grade science tells us that moving a coil of wire over a magnet will generate a voltage. And thus we have our output. Nice thing about dynamic microphones is they don't require any voltage to operate, and they can be extremely rugged. I've seen people pound nails with a dynamic microphone. In fact, in some of my classes, I throw the dynamic microphone across the room and hits the wall, and not a problem. So they're very rugged. They don't require power. They can take a lot of abuse, but they're not very sensitive, so you have to be fairly close to a dynamic microphone. If you're a soft-spoken talker, you've got to be right up on that microphone for it to pick you up. On the other hand, a condenser microphone is a very thin gold-coated membrane that's suspended in front of another metal plate, and they're both electrically charged. They're separated by an insulating spacer ring, and that forms what we call in the electrical world a condenser or capacitor. And as the diaphragm moves in relation to the backplane, it generates a very tiny voltage which needs to be boosted by an amplifier inside the microphone. And that's primarily why condenser microphones require a voltage to operate, whether it be a battery or something called phantom power coming down the mic line. And that's to provide that voltage to run the amplifier and circuitry inside the mic. In some of the big studio microphones, that voltage is also used to charge the backplate and the diaphragm of the microphone. Because I don't have this big motor assembly associated with a condenser microphone, I get a lot more transient response, I get a lot more articulation on a voice, I get a lot more sensitivity, and I can physically make a condenser microphone extremely tiny without sacrificing performance. A dynamic microphone, if I try to make it tiny, if I want to make a lavalier dynamic microphone, it's virtually impossible to do, because as I get down to a certain size, the performance of the microphone just deteriorates rapidly. Which is why if you've watched any of the old TV shows, the old black and white shows from the 50s and the newscasters, they were wearing these big giant microphones on a cord around their neck. That was the dynamic lavalier microphone from the good old days.
So on a condenser, you said you can make a condenser really small and it'll still work. Does the low-end frequency response, is that affected if you make a condenser really small?
No, it's not. And that's the beauty of a condenser. The diaphragm can be made very tiny because there's not a lot of mass there. That BP896 that I talked about a moment ago, that has a 0.25 millimeter diameter capsule, and it picks up low frequencies very well.
Wait, say that again? 0.25?
Yeah, 0.25 millimeters.
Whoa.
It's tiny. In fact, the microphone capsule's not much larger than the diameter of the little wire that it's connected to.
All right.
On your typical smartphone, I won't mention which brand of smartphone I use, but it has a little itty-bitty hole down at the bottom next to where you plug the headphone in, and that's the microphone for that smartphone. And it's probably an 1/8 inch in diameter, and it's a little condenser microphone inside there. And some smartphones actually sound pretty good.
Yeah, I've heard some good sounding smartphones, and I've heard some horrible sounding landlines too, believe it or not. I mean,
well, yeah, I mean it goes back to the technology of the day,
right? So, what about a ribbon mic then? What kind of how does that take in the sound?
A ribbon mic is fundamentally the purest form of transducer out there. We basically imagine, again, I came from Chicago, so imagine taking a Wrigley's gum wrapper and peeling the little piece of foil off the paper, and then taking the little piece of foil and folding it into a little tiny accordion, and then suspending that on a pair of wires in a very big magnet. As air hits the ribbon, it causes it to move back and forth inside that magnetic field, cutting the magnetic field lines and generating a little tiny voltage, which is boosted in old ribbon microphones by a transformer. Which is why if you go to any vintage ribbon microphone webpage or book or whatever, they will tell you, one, never ever blow into your ribbon microphone. Don't lay your ribbon microphone on its side. And never, ever connect a ribbon microphone to a circuit that has active voltage or phantom power on it. Because blowing into an old ribbon microphone will blow the ribbon out of the magnet structure. Laying it on its side will cause the ribbon to sag and deform. And plugging the microphone into an active circuit with phantom power on it will cause the ribbon to act like a fuse and blow with a poof.
Oh.
Fortunately, the new ribbon microphones, such as the ones that we offer, our 4080 and 4081, are actually active microphones and require phantom power, and you can blow into them and lay them on their sides. The ribbons are fairly well protected.
Oh, okay. They're protected and okay.
Mm-hmm.
That's interesting. And then the crystal carbon microphones, the very original ones that aren't much used anymore, how did they capture the sound?
Well, the carbon microphones were basically carbon granules that were attached to a diaphragm, and as the diaphragm moved, the carbon granules rattled around in there and generated electricity. Crystal microphone worked by a crystal being agitated again, and it generated instead of the ceramic material, it would generate a little tiny voltage. Crystal microphones, believe it or not, are still used today by harmonica players. The guys that want that classic bitey harmonica sound, harp players will use a crystal microphone. They'll cup it in their hand, and it'll be something right out of the 40s that they used to use for like calling taxi cabs.
Wow. So does Audio-Technica make any mic pre's or any other gear?
We don't make mic pre's. We make turntables, we make headphones, we make microphones. But I can talk about some mic pre's that I've used if you'd like.
Well, just maybe just an overview of mic pre's and which ones are better and why, kind of thing.
Well, there's two ways to look at it. Okay, typically a podcaster needs to get their audio into a computer, because the computer is going to be what gets it out onto the network. So there's oftentimes we'll talk about a true mic pre is strictly a preamplifier that gives us a line level out that then goes into some other device. Most often, if I'm doing a multi-person podcast, I would use something called an audio interface that has mic pre's built into it. PreSonus makes a thing called a Fire Studio, I think is what it's called, or a Fire Pod, and they make a couple other pieces that are very similar. I can't remember the model numbers off the top of my head. There's several companies that make that.
I use the Focusrite Scarlett.
Focusrite Scarlett's another one. That's the other one I was trying to think of. PreSonus makes some real nice ones. AudioBox VLZs, I think, is the ones I've got. There's several companies that make these. And what these do is they not only give you the microphone preamp, because the microphones put out a very, very tiny signal that has to be boosted to make it usable for a lot of things. So the preamp basically does that. It preamplifies the sound and brings it up to what we call a line level. Line level would be what the output of your music player that plays your background music would be feeding into your system. The interface allows us to do a couple of different things. It allows us to provide mic pre's and match the mic pre's to the microphones. It allows us to provide phantom power for the microphones that require it, condenser microphones and so forth. It allows us some control over the signal that's coming in. And then with the appropriate software, it allows us to mix those audio signals together and process them. A lot of times I'll use the Audio Box VLZ, and I'll use the VLZ, which is their virtual control surface software that runs with that allows me to, say, tailor the sound a little bit. Take a little bit of bass away if I've got someone that's really kind of muddy in their talking, or add a little bit of articulation to a voice. Add some soft compression, so if the guy moves around in front of his microphone, the level's going to stay fairly consistent. And then that goes into my recording software or broadcast software that then sends it off to the internet.
Right. So you mentioned the microphone output level, and I know this, that every mic has a different output level. Some are normal, some are stronger, some are not as strong. I remember when I took my little digital recorder to the Guitar Center and I started plugging in all these handhelds because I wanted to buy one, and I had a feeling I didn't want to buy an SM58. I wanted to buy something a little better. So I did all my sound testing there, and the sound level, some mics are just so soft in terms of level, and some are stronger. And I know a lot of people, they use a mic that it does not have a strong output, and they have to crank their mic pre almost all the way up. And you mentioned before about matching the mic pre to the mic. Is that what you were talking about?
Correct. Typically, a microphone pre will have a good microphone pre will have two controls. It'll have a level control. It'll have a trim control. The trim control, now, when I do a multi-person event, so I've got 4 talkers and a host, I'll use a little recording console, which is a little mixer that also has a USB output or a FireWire output to go into the software. And what that does is it gives me a little bit more control over the audio and a way to monitor the audio. So what I've got is the trim control basically matches the output of the microphone to the input of the electronics. And then the gain control, or the volume sliders, which are actually used to mix the signals. So we can blend guest 1, guest 2, guest 3 in the host. The trim control, depending on the microphones and how the microphone's built, let's look at dynamic microphones for a moment. Dynamic microphones by nature have a fairly low output level. Some dynamic microphones will use neodymium magnets, which is a real strong magnet material, and that will give you a hotter output. So several of our dynamic microphones they'll say high energy in the descriptor, and that means it's got a neodymium magnet structure in it, which is going to give you a hotter output. Typically, the dynamic microphone, the trim control on a mixer is set about 3 o'clock. Condenser microphones, on the other hand, because they have active electronics in them that are boosting the audio output, are typically hotter or more sensitive than the dynamic equivalent. And so in that case, the trim control is backed off to maybe 12 o'clock or 11 o'clock, depending on the type of microphone.
Right.
The other thing that you have to be aware of, especially if it's someone that's using, I got these vintage ribbon microphones. I really want this to be. I'm doing a podcast, or maybe I'm doing a video podcast as well. So I want to look really cool, like an old radio station. So I found these vintage microphones on the internet. I bought them all for a great price. They're ribbon mics. They say NBC across the top, or CBS or ABC with the cool little things. And man, they look really cool. The problem with those microphones, if I try and connect them into a modern day mic pre or a modern day audio interface, something called the impedance, which is the impedance is measured in ohms. It's an AC voltage measurement as opposed to a DC voltage measurement, which is also measured in ohms. The impedance match between the old vintage ribbon microphones and the modern mic pre's was not the same. So you get a mismatch, and that can cause you some signal issues as well. Most modern microphones, condensers, dynamics, and so forth that we manufacture, that other current microphone manufacturers offer, are designed to properly match into a modern mic pre circuit. Some may be louder than others, some may be softer than others, but they're really designed to match into a modern mic pre circuit. So now you basically set the trim on your input. You set the trim on your input so that the loudest sound of the talker, and I do this for every talker, so the loudest sound of that talker just barely illuminates the little clip light or goes into the red. Then from there, I use the fader control on my little mixer to actually blend the sound that I want of the 3 talkers. The other nice thing about using a mixer as opposed to just a mic pre, if I'm dealing with multiple talkers, is I can now do a headphone mix or a cue mix to give them give them the headphone audio that they need to hear themselves, because obviously I can have speakers turned on in the room, especially if I'm bringing other elements in, if I'm bringing somebody that's in a faraway location in. So I've got three people in the room with me, myself, and I'm bringing out a guest in over the internet or over a telephone hookup or some other device. I need to have some way for everybody to hear everybody. So that's where I use the headphone or the Q mix, and that's a common broadcast situation where I'll use a Q mix to give everybody their own headphone levels. And then each person has a little headphone box, and they can adjust the levels accordingly. Some people like their headphones loud, some people don't like them as loud.
Right. And the faders give you a way to mix,
and
mix the levels so it sounds good to them. Yeah.
The faders allow me to mix the levels so that it sounds good to me, or what's going to air, for lack of better terms.
Right.
In other words, if I've got a loud talker and a soft talker, I might want to bring the soft talker up a little bit in the mix so that everybody sounds consistent. And that's what the faders do in the mixer.
Right. Different microphones sound different on different people, and I know in the studio we used to do this. Like a singer would come in, Mariah Carey comes in, and it's like we got 5 microphones set up ready to go, and she goes and sings a little into each one, and the engineers inside listening, and we're like, oh, that one right there, the AKG C12, that's the one for you. First of all, I was going to say, how can podcasters figure out which mic sounds the best for them? And I guess the answer is, well, you're just going to have to buy them and try them. But what is it about a microphone that makes it sound good on some people and not good on others?
Well, it's funny. The analogy that I use is microphones are like the paint chips when you walk into a hardware store, right? You've got all different colors.
Right.
And you need to find one that sounds good on your voice. And the best way is, some dealers, you can actually go in and try microphones. There's a really big superstore in New York City that you can go in, and they've got a microphone room that has almost every microphone known to mankind, and you can go in there with a pair of headphones and listen to all these microphones. Sometimes a dealer will let you buy one, and if it doesn't sound right on your voice, bring it back, or you can try it out in the store. But it's really a personal preference as to what sounds good on people's voices. I've actually tried our $3,000 boutique microphone on somebody and liked our $1,000 mic better on that person just because of the way their voice sounds. It's a personal preference thing, and everybody's voice sounds a little bit different. The nice thing, if you buy a microphone that has a fairly, and this is another piece to this puzzle, is some microphones will tailor their response. And the manufacturers will tailor the response of the microphone. We do this, and so do all the other major mic companies. They'll tailor the microphone response for a certain type of sound. So we have a series of studio microphones, and there's some podcasters that'll use some of the 40 series mics, especially in a bigger type show, where we have 7 different microphones that look pretty much alike. A couple of them are silver and most of them are black. Every one of those has its own sonic signature, or palette of colors, we call it. And we have some descriptors for those, but it's really hard to describe. It's easy to describe things visually. The walls of my office are beige. My computer is silver with a black trim. I've got a drink cup that's got green letters on it on my desk, and I'm wearing, a blue shirt. We can describe that very easy visually. It's very difficult to describe how something sounds. And, you'll hear terms like tubby and muddy and harsh and horny and crackly and sizzly and brittle and bright and present and airy and all that. We're trying to use descriptive words to define something it's really hard to describe. We tailor microphones for different things and for different types of voices, for different types of sounds. But the best thing to do if you have the opportunity is to try microphones. If you know someone that has a mic, kill that.
Yeah.
If you know someone that has a microphone that you might want to try it. Record something with it. Borrow it and see if you can use it in a podcast and listen to what it sounds like. That's probably the only way to do it. There are some pretty common things, like most condenser microphones will give you more articulation. Most dynamic microphones are going to have a presence peak in them that are going to give you a slight boost in the mid-range. And the microphone manufacturers do that because the original sound systems back in the 50s weren't as good as what we have today. And to compensate for the fact that the speaker systems weren't very performance good at the voice range,
Right.
they would add a little boost in the presence range. The SM58, for example, has a very well-known presence peak, which makes the vocals, gives them the characteristic that a lot of people like. I personally don't like that. I'd rather use some equalization in my mixer or control surface to tailor the sound the way I want it.
Right.
But there's a microphone that I use when I do my voice work in my studio, and it's the one I go to all the time, even though I've got all the AT mics available if I want them. So.
Right. So what do most engineers not know about microphones? What do you tell them and they're like, really?
I think most engineers don't realize that microphone technology has not changed a whole lot, but has come a long way than it has been. And they just think microphones are microphones. I don't think most engineers realize that microphones really do have a sonic signature or a palette of colors. And I'll bet you that most people don't know what XLR means. Huh. We all use it. We all talk about it, but I bet most engineers out there don't know what XLR stands for. We all use XLR plugs. We all use XLR cables.
See, you're stumping me here.
Stumping you. Okay, this, by the way, if you take my class, I teach classes. If you take one of my classes and on the midterm, this is worth 6 points as a bonus question. What does XLR stand for? Well, you need to know this in case you're standing on the street corner and a man hops out of a fast taxi and says, "What's XLR mean?"
Yeah,
so
sir,
ready?
for $3 million, what is XLR?
For $3 million, here it comes. And there's actually a website that's called The Brief History of the XLR Connector. It's out there. The thing was written by a gentleman named Ray Rayburn, who is an audio guy from Chicago and a friend of mine. But here we go. XLR. X stands for the X Series connector, manufactured by the Canon Connector Company, spelled C-A-N-N-O-N. No relation to the people that make the fine cameras and optics. L stands for latching or lock, and R stands for rubber or resilient. And the original XLR connector was actually a power connector for movie cameras. And the audio industry embraced it because before the XLR connectors, we used plugs that were twice the diameter. They were huge. And they weren't they weren't sleek and so on. And so the XLR connector was a smaller connector as microphones were getting smaller and cables were getting smaller. And they locked together, so if you pulled your mic cord along the ground, it wouldn't come unplugged.
That's so funny because I remember when I was in the studios in the 90s making records, some engineers would say, like when it came down to the connector, like, oh, we need a 1/4 inch to something, and they'd say 1/4 inch to Canon.
Yeah,
and I was like, I never knew what that meant. I was like, I didn't even ask. I just was like, I knew it was XLR, but I didn't know why.
Yeah, 1/4 inch to Canon. Canon connectors is the, of course, it's become a ubiquitous term today. We just like we call, facial tissues Kleenex, we call mic connectors XLRs.
Right, that one.
Or Canon, or guys have been, guys have been in the industry for a while. Call them, I need a Canon cable. Okay, everybody knows what that is.
Right. I think those guys are gone though. They've retired.
Yeah, probably.
Maybe, I don't know. Well, this has been great. I mean, I'm really glad we got to go into, some of the tech specs of these microphones and the different kinds. I think this is really helpful. Yeah, I mean, there's so many mics to choose from. So I guess, do you have anything you want to share to wrap it up?
In parting comments, I mean, you can find out more information on any of our products by visiting our website, www.audio-technica.com. There is a product profile page on every microphone that gives you specification information. There's frequency response charts. There's polar pattern charts. There's kind of everything you need. Microphones are, to anyone that does anything with the voice, the microphone is your instrument. A guitar player is going to pick a guitar that's easy to play, that has the sound he wants, that's comfortable. From a podcaster, from someone that's producing, from someone that's an on-air person, the microphone is your tool. It's your instrument. Find something that works for you. If you're a producer that's producing shows where you're bringing guests in, find a generic microphone that's got a good all-around sound for all types of voices. Don't be afraid to experiment and push the envelope a little bit. There's some really cool things out there that I've used that I wouldn't use them for what they're originally designed for, but they actually work out really well. And by all means, take good care of your microphones. keep them covered if you're not using them. It keeps the dust and dirt out of them. One of the problems that happens over time is the grills and the head cases get full of crud from people talking into microphones. So, every so often I'll take the head cases off my microphones. I'll clean them really good with a toothbrush and warm soapy water. The little foam piece that's inside, the extra windscreen piece, I'll wash those and dry them out good and so on, because they do get full of crud, and eventually I've seen microphones that have come back to our service department where there's no way sound can get through the grill because it's just so crudded up. Oh, it's disgustingly gross. And the service tech puts the big rubber gloves on and he unscrews the head case and throws it away and puts a new one. Doesn't even bother trying to do anything with it.
Oh man.
Microphones are precision instruments. They're pretty robust in most cases, but if you drop one, especially a condenser microphone, you could knock the caps out of alignment.
Right.
And for those of you that are working in very humid environments and using condenser microphones, whether you be on the coast or down south, Houston, Texas, Florida, any place where you've got a lot of moisture in the air, if you fire up your system and you hear what sounds like bacon sizzling in the background, using condenser microphones, more likely than not what's happened is moisture has gotten on the insulating spacer ring and is basically shorting out the capsule.
Oh.
And you're getting that little sizzly bacon frying sound. Simply take the microphone and put it in a Tupperware or plastic container with rice in it and let it sit for a few hours. And that'll work and dry it out and you'll be fine.
That's interesting. Rice.
No reason to panic. It's like dropping your phone into the loo. Before you turn it back on, just put it in a thing full of rice for a couple of days and it'll dry it right out.
Right.
Same
That's
thing.
interesting.
Yeah.
Hey, I have a question. Someone told me that they don't use USB microphones because there's always a little hum that they hear. I personally have never heard it. Have you heard about any problem?
I've never heard the hum. I'm on a USB mic right now, and I've never heard the hum. Depends on, I am connected to a USB cable that has the RFI filters on it. It's a signal cable. It is a digital signal cable, so it's not like an analog audio cable where you could potentially get hum induced into it. But it does, there might be some EMI or something getting into their system someplace that they think it's the USB mic and it may not, it may be somewhere else.
Right. Exactly. That's probably what happened. So this has been great. Thank you, Steve, for being on the Podcast Engineering Show.
Well, thank you very much, and hopefully we can come back and do it again sometime.
I know. Well, I already wanted to ask you about the course that you teach and what are the modules, everything. We'll have to talk more. So, Steve Savanyu, Director of Educational Services at Audio-Technica U.S. This has been great. Thank you, and thank you for listening. I know you got a lot out of this. I was sitting here taking notes the whole time, so catch us next week for another great episode of the Podcast Engineering Show. And until then, you already know the drill. Sound great.